Hello, everyone. Today we'll be going over how we decided, designed, and made our final product for this project. A new take on the classic Pendulum roller coaster that we've all grown to love.
Hi, my name is Marvin Ortez. I was a part of this project. I am a sophomore majoring in mechanical engineering. My hobbies include guitar playing, working out, and when I graduate, I aspired to become a roller coaster designer, which is why this roller coaster project was very interesting and fun for me.
Hi, my name is Anthony Browning, and I'm a mechanical engineering major student as well. Some of my hobbies are working on motorcycles, cars, and computers.
As you guys already know, my name is Adam Medina, and I'm a mechanical engineering student as well. I hope to one day graduate and be able to work in Norway in the hydropower sector. So now into our reasons for doing this. Starting off, we were really interested in learning about the mechanics behind building roller coasters.
Yeah, and not only did we want to model after a real pendulum ride, but we wanted to challenge the skills we already have on Solidworks and to see how far we can test ourselves and go past our limits. And in order to model after a accurate pendulum ride, we modeled it after a ride called Crazanity, which is located in one of the Six Flags theme parks, and it is currently the largest pendulum ride in the world.
So our overall goal for this project was to create a pendulum roller coaster that wasn't too complex, but was able to show the basic mechanics of the roller coaster. And even if none of us go into the roller coaster industry, we wanted to have this experience so we can prove we could tackle a large project such as this one.
So now we'll be going over some important features of the design and of the product. This won't be everything that'll be included in the document we provided, but it will be some of the things we found to be pretty essential. So starting off, we're just gonna go over the platform in the ride. The platform consists of a rectangular base and two extruded hexagons. The base is there to provide footing for the beams that you'll later see in the ride. And the hexagons are there so that passengers can easily mount and unmount the ride at their discretion.
The next important feature we have is the handled axis. This is important because it connects where the riders go to the support structure. The design is, as you see, a handle connected to an axis, where the handle goes on the horizontal bar of the support structure, and the beam, also known as the axis, has a small hole at the bottom where a nut and bolt can go in order to hold the wheel of the passengers on the handled axis. And this only swings in one direction, but it is only one of the two motions that the ride has as a thrill factor.
Okay, so the next part is the ring. This part has to be strong enough to sustain the weight of swinging and twisting at the same time. This part is essential because it is the part that is most important for rider safety, as the beams in the center need to support the weight.
So here we'll be going over what we call a support superstructure. It's not necessarily a part or an assembly to itself, but rather it's a composition of parts that we thought were important and essential as a unit, right? So here we have the beams, the sockets, the connecting rod, and the pin. And they all work to serve the essential function of holding the handled axis so that the ring can swing as efficiently as it does. And it also holds the ring in stasis before and after the ride is conducted.
Here we have an animation in order to demonstrate the motion, the two motions of the ride. I apologize for that. All right, so as you can see, it starts off with a pretty low velocity and a small angle from the normal, but it quickly increases in velocity and gradually increases the angle with every swing. And the goal is to go up to 120 degrees from the normal. And you can also notice that the wheel is spinning around the axis.
And finally, we'll be going over what we learned doing this project. Starting off, we really learned how to use animation techniques in SolidWorks more effectively than we did before starting this project.
Yeah, and one of the other huge benefits we got from this project is the teamwork. We learned how to communicate, collaborate, and give each other jobs as best as we could for certain skills that we have to be perfectly matched with the jobs. And yep, that's the aspect of teamwork.
Also for this project, like said previously, we wanted to demonstrate the pendulum roller coaster's movement without, making it too complex to where, the average person would not be able to understand what was going on. We also became very comfortable with the tools that we've learned in this class from the day we walked in as a basic line to the day that we left with animations and presentations.
I want to thank everyone that tuned into the presentation so much, and thank you for listening to what we had to say.
Yep, thank you, everybody.
Thanks.